Okay, DJ, so this is the final problem from section 11.4. Number 5. We're supposed to do 2 through 5. So far, I think we're doing a decent job on these. Again, there's no answer key to reference, so that's what sucks. All right, so they gave us our y prime again. Here it is right here. We set it equal to 0. To solve it, we end up getting y0 or y is 1. So here are our two equilibrium points. Our y has to always be greater than 0 because of the square root, right? So that's why they have that condition. Now, if you look to the bottom left here, I actually graphed, I believe, the derivative to show you that starting at 0 here to 1 there, notice how it's below the x-axis, so we know that the derivative is negative there. And above the x-axis, of course, it's positive. Okay? And that will bear out, I think, on the next screen here. But anyways, let's first do the second derivative, and then we have to do the phase lines, which are right there. Okay, so let's do the second derivative first. So how do I do the second derivative? Well, I have to do the derivative, of course, of y minus square root of y. And remember, square root of y is y to the 1/2. So follow the purple now. The derivative of y, of course, is just 1, y prime, minus the derivative of y to the 1/2. Remember, the 1/2 comes in front. And then y is now 1/2 minus 1 power, right? Remember, you take away 1 to the exponent, so we get negative 1/2 y prime. We can factor out our y prime, and we have 1 minus 1/2 y negative to the negative 1/2, which means y prime times 1 minus 1/2 is 1 over 2. And remember, that negative means it's a square root, but it's in the denominator. Okay? So continuing on, we know our y prime is y minus square root y times 1 minus 1 over 2 square root y. That is actually y double prime. Okay? So now what? Well, what we have to understand is this part here of the y double prime can never equal 0, right? If I plug in 0 there, actually it goes to infinity. So with the square root and everything, you can't make that value go to 0. Right? Pretty sure you can't. Why am I having second thoughts right now? Can I take 1 solving for 0? I could times both sides by 2 square root of y. Square root of y is 1/2. Oh, shoot. It can be 0. So we do have an inflection point. Good thing I checked. So if the square root of y is 1/2, DJ, that means y is 1/2 squared, or 1/4, right? So I stand corrected. That means y equals 1/4. And here's the work down here to prove that. But anyways, let's get our phase line in. Follow the purple. Let's start with the first derivative. We know we have two equilibrium points at 0 and 1. So we don't have to worry about it being less than 0, because that was one of our constraints. So we're going to look between 0 and 1. And if I plug in, you could see the work actually right here in red and purple now. But if I plug in, let's say a 1/2, that's less than 1, I get a value less than 0. If I plug in a value bigger than 1, like let's say square root of 2, like plugging in 2 is greater than 1, 2 minus square root of 2, of course, is positive. So what I know is, as I showed you in the graph here, we know between 0 and 1 it's negative. When it's greater than 1, it's positive. And here again is the algebra to prove it. Okay. So we know again that the first derivative is negative between 0 and 1. And then it's positive after y is positive 1. We also just figured out we have an inflection point somewhere around 1/4 right there, right? So now what? Well, let's do the same thing with double prime. If I plug in, let's say 1/2, we know the first part of the value is negative. If I plug in 1/2 there, do I also get something that's negative? Let me think. Okay, DJ, so you can't see, I just pulled up the calculator on my phone. So if I do plug in 1/2 between 0 and 1 into the double integral, where was my work here, damn it? All right, so we already know that that part right there, if you're following what I just circled in purple, when I plug in 1/2, I do get a negative value. And then when I plug in 1/2 over here, I got a positive value. So that's how I know y double prime is negative, and then it's going to switch to positive. But now, of course, what I have to worry about is there's that reflection point, right? Or inflection point at 1/4. So that logic is not going to quite follow right. Let me fix my work here, damn it. So we have to also consider, what was it, 1/4. Okay, so here's the deal. I think we can do this. So we just plugged in 1/2. So in between here is negative. That means over here it should be positive. And then greater than 1 will also be positive as well. Okay, so from 0 to 1/4, it's double prime is positive. From 1/4 to 1, it's negative. When it's greater than 1, it's positive, because it should always alternate, right? Hopefully, you know what? We're just going to go with it. So that means between 0 and 1/4, I know it's going to be going down, but it's going to be concave up. So that means it's going down something. I mean, how can it go down and concave up? So, crap. It's going something like this. And then, but that's where I'm in between. Damn it. That's right. It can't be. Okay, so between 0 and 1/4, it's concave down. So it must be doing something like this, DJ. Okay? And then between 1/4 and 1, so at 1/4 and 1, there's an inflection point. So then it kind of curves down like that. Now between 1 and, oh God, I'm losing my train of thought. This stuff is kicking my ass. So it's positive and it's concave up. So anyways, DJ, it's something like that, for God's sakes. Okay? And that's the best I can do, buddy. So just make sure you show all this work, and I guess really we got to make sure we prove to the teacher that we're putting forth a lot of effort, and hopefully we can keep doing well on any quiz or test that's thrown our way, right? But that's it for 11.4, man. Hopefully I did a decent job for us.